Hi everyone. So this is the next section. I thought I'd stop it there for people who are not too interested in the technicals of how the personality trait predictor is actually coded. But for some of you, it might be interesting. So let's open that up. Here I am in Mathematica, um, and what I'm doing is using data bins to keep my data. That's bin and bin 2. So there's two major data sets, data and accuracy. And God, I sorry, but you'll get to see all my sloppy coding. But I think solid coding is just maybe a bit obvious that I'm self-taught with it, but it's effective coding. And what we're doing here is calling for the Sun uh, International Astronomers Union data. So for the Sun, for the Moon, for Mercury, um, for Venus, for Mars, for Jupiter, Saturn, Uranus, Neptune. Um, And then because Pluto is not officially a planet, we're going to have to calculate it down a few lines in a separate system. But then we also want Mercury retrograde status, Venus retrograde status, Mars retrograde status, Jupiter retrograde status, Saturn retrograde status, Uranus retrograde status, and Neptune retrograde status. Once we call on Mathematica's built-in astronomy software to provide that, then we can go ahead and do the same thing with the so-called minor planet data for Pluto, and same thing, get the retrograde apparent motion query to get the Pluto retrograde status as well. Then what we're doing is establishing, oh, here I am. I am building a training set, um, which is from all of the data in the data bin, that first data bin, um, which contains all of these statuses from people who have come before you, from when you go to to the website. Everybody who's come before you has put in their birth information, and really, I don't keep their birth information. I just keep the planetary data, the astronomy data, if they click on OK to retain. Okay, so then I have some classification strategies here. I want high performance goal is quality. I want high quality. I was, you can see in blue, using support vector machine for a while, but then I realized that I should just go for quality versus the most, you know, tricky of the methods. I should just go for quality because since those 1,200 people who form mm, uh, the basis for for the AI, because they agreed to have their astronomy data kept. Since then, Mathematica has improved the methods for classification for AI, and so the support vector machine method is no longer um, the number one way of doing things. So that's why I commented it out. That's what the blue means, is commented out. It's not being evaluated, that support vector machine part. Okay, so our test set is going to be this association, 18, I believe, qualities to your birth information whenever you go to the website and put in your birth information. We're calling up in the above lines the sun placement, the moon placement, Mercury placement. Is Mercury retrograde, yes or no? Same with Venus, Venus retrograde, Mars, Mars retrograde, and so on. So there's a then we just call that extroversion classification based on your data, and then the next few lines just generate the circles with the word extrovert or introvert, the circle being red or black depending on whether you agree or not with that assessment. Same with agreeableness, same with conscientiousness, same with neuroticism, same with openness. And what else? Oh yeah, and then the next few lines just set uh, so-called this accuracy, which is the accuracy of your visit, not visits before you, but just the visit your that represents you coming to the website. And what else? If okay to retain, um, then it adds the data, your data, to the data bin representing all the prior datas. There's n plus 1, one gets added, one set of data, and that's your data. Same with if okay to retain is true, then we add to the second data bin just the accuracies uh, of your visit. And we're going to use the set of all the accuracies to generate the charts underneath the circles, which represents the accuracy rates. And next in this little program is the plot of the normal distributions, the blue curves with the orange dashes representing the p-values. And so these are just the formulas for those. There's 5 of these, one for each of the big 5 personality traits. See agreeableness, conscientiousness, neuroticism, openness, and extroversion. And then similarly to represent the text that's underneath the blue graphs, there's some fresh calculations for the prediction accuracy, including, oh no, at this point it's not including your personal accuracy, because after all, you may or may not want the information to be retained, so this is going to be calculated regardless of whether you clicked on OK to retain. All right. So let's see what this looks like when we run it. And I thought this is going to be worthwhile to show you because it does show some extra things here within Mathematica software that are not viewable on the web page. Just some of the cool graphs that get generated during the calculation. After the calculation, the output looks the same, but there's some things that are missing that just are not included in on the web page that I think are kind of neat. And so that's really my motivation for having this podcast, or this, what is this, a video cast or whatever it is. So let's make up a birth date, April 1st, 1970, birth time 7 p.m. Let's have it be in New York City that the birth happened. Actually, I think we can just put in New York City, but let's be very careful and put in New York, New York. All right. And so here I'm going to just tick off every other box, making sure to avoid the OK to retain because this is a made-up person. And check out what happens next. It's pretty cool. All right. There we go. Submit. And it takes about the same amount of time as the website. But there's some really cool intermediary stuff that goes on. This is the cloud deploy function, and this is the embeddable code. um, you're welcome to go visit it if you wish. Um, it's a public, web page. That's how you can see it on Astro, for that matter. Also, you can see it on KeplerQuiz.com too. Okay, so this is being evaluated. You can tell because there's a little black line here. It's being evaluated within Mathematica. Now, this is what I wanted to show you. This is the learning curve for each of the 5 personality traits, and you can see it is going up as the number of training examples increases to the right. So it is learning. That's what I wanted to show you. All except this one. This one isn't learning that much, really. Okay. Let's see. Nearest neighbors. I think we're at the 4th one. Yeah, that one's definitely learning. Oh, that was the 5th one. That was for the extroversion. And here you can see the circles are a lot bigger. That's because I made them bigger. Okay. And so you can see that according to the AI, the person with that made up birth information is agreeable, or should, at least this is what the learning model based on the birth data seems to suggest, is that the person might be agreeable, might be an introvert, might be conscientious, might be not neurotic, might be open, and the red is where it disagrees with me. So, and then here's the data. This should be familiar to you at this point. Yeah. And so I really just wanted to show you that, yeah, there is AI going on. There is a classification strategy going on that is real. That is I mean, the code is not fancy. It's not sophisticated on the face of it, but underneath there is a lot of good stuff going on, a lot of good math, some real machine learning going on. So that's it. Thank you. Let me know what you think.